It's so great to be back at another Interledger Summit. At the risk of being a bit repetitive, I also want to thank Brianna and the whole staff for putting together such an amazing event once again. When the community didn't have the Interledger Foundation, we didn't have events like this, and it's just incredible to see so many people interested in the technology, and it's just an absolute pleasure to be speaking to you today. So the project I'm going to talk about is called Dassie. It's something that I announced a year ago at the last summit and that I've been working on ever since. Dassie is an open source project, and as we go into the presentation, I'll tell you a little bit more about it. But before I get into that, I want to kind of set a foundation here. Obviously, we're at the Interledger Summit, so probably most of you will have your own answers to this question. Why are you interested in Interledger? I'll give you my answer, which is pretty technical, pretty unique to me, I guess, but maybe you'll find it interesting. So as a developer, I kind of grew up with the internet and the web, and I found it to be just this absolutely magical tool. It's sort of like something that allows my software to communicate with software all around the world. You can build applications that brings people together and connects people, and it just feels like you have some kind of psionic superpower where you can talk to other computers around the world. And at the same time, as a tool, it sort of stays in the background. And I just found that experience to be very, very powerful. But the second you try to do anything like move money around, that whole experience goes away. So for me, the idea of Interledger and getting to Interledger Protocol was really all about trying to figure out how to bring that magical experience to money. And so to do that, we first have to kind of break down what that experience consists of. Like, why does the internet feel so magical to us developers as a tool? And I think a tool is magical when it sort of just makes your life easier. You don't have to think about it very much. It works instantly. You don't sit there waiting, okay, when is this thing going to actually complete? It's very easy to pick up, so there's not a lot of complexity if you're just using it. Maybe it does a lot of complicated things in the background, but it's not necessarily something that you as a user or as a developer using this tool have to think about. It's also very important that it grows with you. So the internet is something that works great for my prototype, my hobby project that I'm doing over in my garage, but it also works for Google and some of these giant tech companies that are serving billions of people. So it's really incredibly scalable. And it's also kind of feels elegant, right? It's just an elegant solution to the problem. And I think that's important because that's what makes you excited to work with it and excited to pick it up. And so if you wanted to bring some of these things to money, how would you do it? And for me, I kind of got my start in this space, in this industry, in blockchain. I got into Bitcoin very early on. And I was kind of attracted to it as like, maybe this is the TCP/IP for money. Some people have said that. And so, I kind of got very excited initially. But then when you kind of look at this list and you look at, what it's like to work with a lot of blockchain technology, it's not really instant, right? You're waiting for a Bitcoin block to be generated 10 minutes later. So you're kind of waiting around. It makes your life easier, but it also adds a lot of new complexity. I'm famous for having lost a crypto wallet just by losing my keys. So that certainly didn't make my life any easier. It's not necessarily easy to pick up. There's a lot of things you need to learn if you want to use blockchain. And the scalability is also not really there, right? Like, we have a lot of issues with blockchain scalability because it's a shared ledger. Everybody needs to hear about every transaction that's made on the entire system. And so it doesn't really feel scalable. And maybe in a more subtle sense, there's also a lack of scalability because, there's this economic aspect to blockchain where each blockchain has their own built-in token, and whoever got in early in that token sort of gets rich, and then everyone else who has to buy in later gets screwed. And so that's not a very equitable way to build a global piece of infrastructure. And so how is Interledger different? How does Interledger sort that out? So Interledger is kind of the magical protocol for money because it's a lot more like TCP/IP. It doesn't have a built-in token. It doesn't have anybody getting rich other than, if they build a great company on top of it. And it is supposed to, and I don't know if we're quite there yet in terms of the actual developer experience, but I think we're on the path towards making it feel like that super powerful, elegant tool that you can just pick up. So for me, that's what Interledger represents. It's the true TCP/IP for money. It's a magical tool for if you want to just move money from one place to another and not have to think about all the details. That's what Interledger Protocol is designed to be able to do. Okay, now we already have Interledger Protocol, so why am I starting this project Dassie? What is Dassie and why do we need it? And so, over the past, that's coming on almost 10 years now that we've been working on Interledger, one of the problems that we kept running into is people wanted to pick up the technology, but there wasn't any way for them to get onto the network. There wasn't anyone to connect to. That could be because some of the wallets were geographically limited. Sometimes it was because of expensive or complex onboarding processes. Sometimes it was because you needed to have a certain amount of minimum volume for a wallet to really be interested in your business. And so there's always been this hurdle of how do I actually connect to the network. And kind of going back to the blockchain analogy, well, that's one problem that I didn't experience when I was working with Bitcoin. You just download the Bitcoin client and you're good to go. You're pretty much on the network. And so the reason that works is because the network is just made up of the users. It's a peer-to-peer network. So in a way, we are the network, right? And we can do that for Interledger too. So we can make a peer-to-peer implementation of the protocol where you just spin up a node, it connects to other nodes that are running the same software, and now you form a network, and now you can transact with each other using Interledger. Now, there are definitely some challenges with that. Interledger wasn't really designed for that. Originally, the vision was much more like a more explicit peering-based protocol. So, everybody kind of manually manages their nodes, puts a lot of effort into deciding who to peer with, and so on. And that's kind of baked into some of the assumptions behind Interledger. And so the challenge with building something like Dassie is, can you make it so that everything is automatic? Because Dassie should feel magical. It should be, you just download it automatically finds other Dassie nodes to connect to, it automatically picks a node to peer with and actually do the financial part of the system, and actually doing the settlement automatically as well, so you don't have to constantly manage your liquidity. My background is I worked at a company called Ripple, where we also built kind of credit networks that were peer-to-peer based. And one of the biggest issues we ran into is settlement is something that banks do, and of course they have employees worried about reconciliation and so on. But when you're asking individual users who are just trying to build an application or something to worry about settlement and reconciliation, their eyes glaze over and they don't do it. And so you get all kinds of liquidity issues in that network. And so all of that has to be automatic for Dassie to feel magical. So now I want to kind of give you a little bit of an explanation of how Dassie works. There's definitely, because it uses Interledger, there's a lot of overlap with how Interledger works, but there's still some nuances. So I'm going to represent a Dassie node as kind of a circle. It's sort of the universal language of peer-to-peer language, peer-to-peer network talks is that we use dots and lines, so you get a lot of those. Now, one node by itself is not very interesting. It doesn't make up a network, so we're going to have a second node, and we're going to have them peer with each other. So now they are connected to each other. They can send Interledger packets between each other. And when they've sent a bunch of packets, they might send some real money to settle the traffic and settle those transactions. And so that's how they're able to move money around. Now, again, still not very interesting. I think this is sort of something that already exists. For example, if you're familiar with the Bitcoin Lightning Network, so that's a network where it sits on top of a blockchain. It uses that underlying blockchain for settlement, but then the actual transactions are just from node to node. So it's actually quite similar up to this point. Well, what if we wanted to introduce another currency? Now, we can't just add this new currency to the network because the amounts are different. The currency is going to be settled on a different ledger, so the existing nodes that are used to settling on one ledger are not going to understand that. And so the way we're going to do that is we're essentially going to create a whole another separate network. In my previous talk, I called this a subnet. And then we're going to have one node that is just present on both networks, and it takes care of the currency exchange. And so you can sort of think of the purple part of the system as one network, and then the yellow part of the system is another network, and there's just one node that happens to be part of both. And through the magic of Interledger, we're able to translate from one currency to the other, and we can still make a transaction from anywhere within any of these networks. Now, when I actually went to implement this, usually practice is a good way to find out if your theory is any good. And it turned out that this is much more complicated than I thought it would be, because you're essentially routing within each network, and then you're routing again across networks, and you have 2 layers of routing, and that just gets very complex. And so just to kind of illustrate this, now I sort of think of Dassie as just one big network, and the only difference is that between any pair of nodes, they might use one settlement mechanism or another settlement mechanism, but you just have one network. And it may be a way to explain this a little bit more, if it's not quite clicked yet, is previously a Dassie interledger address would look something like this. So you have G, which is always the global interledger, so that's sort of the global instance of interledger. Das means Dassie, so this is like all the Dassie nodes on interledger. But then we had another sub-identifier, which is for this subnetwork. And so the subnetwork is sort of partitioning the overall Dassie network into a bunch of different subnetworks. And then you have the specific node. And so by getting rid of the subnetworks, we get rid of that entire layer of the hierarchy. There's no more subnetworks, and now we just have all the Dassie nodes are part of one global network. And that made routing a lot easier. So that's one of the biggest changes since I last gave a talk about Dassie. We sort of combined it into one network. All right. Now, a different way of thinking about this is, you're building this Dassie software, and ideally, eventually, we want to support like all the ledgers in the world and every possible way of settling. It really should be universal as much as possible. And when we had these subnetworks, I realized that it was going to be an issue every time you wanted to add a new settlement mechanism. So let's say you wanted to add Bitcoin, or you wanted to add XRP, or some other cryptocurrency, or maybe some totally different way of settling. You first had to figure out how to get some nodes that people would run so you get a large enough subnetwork to make it viable. And so the network building was sort of something you'd have to do again and again and again for each ledger. But by combining it from a bunch of disparate subnetworks into one big network, now there's already a network. You just connect to the Dassie network. And so the network building is something that we can solve once. We can build the Dassie network up. And then even if there's only one other person that settles using the currency that you want to settle in, that's enough. You don't have to have enough nodes to make like a viable subnetwork. Now, another thing that every peer-to-peer network has to solve is Sybil resistance. And I know this is where it gets a little bit technical, but please bear with me. It's not as complicated as it sounds. So a Sybil attack is when somebody creates a lot of fake nodes and joins a network with the purpose of maybe outvoting everyone else or overwhelming the network in some way. And so whenever you're building a peer-to-peer network, you have to find some way to impose a kind of a cost onto people creating nodes so that you don't get overwhelmed by fake nodes. Now, the way that the Bitcoin Lightning Network does this is it says, well, you already have to have some Bitcoin on the Bitcoin ledger. And so if you want to join the Lightning Network, well, you have to prove that you own these Bitcoin. And you have to kind of show the ownership of that. And so that prevents people from creating like huge amounts of fake nodes and overwhelming the routing algorithm, for example. Now, what that means, though, is that the solution using the Bitcoin ledger only works for the Bitcoin ledger. So what if we want to use a different ledger? Well, then we have to come up with another Sybil resistance solution. And so it's, again, a problem that we have to solve once for each ledger. And so I moved away from that model and towards a model where the nodes use an interledger payment to register with other Dassie nodes, and that's how we impose a cost. And because it's an interledger payment, it's ledger agnostic, and therefore we can solve this problem once, and we don't have to solve it again and again for each new ledger that we integrate. Another thing that isn't implemented yet, but something that I'm thinking about, is how liquidity management works. So the initial approach that you might take is saying, okay, well, we're going to send money for, like, money's coming in on this ledger, we're sending it out on that ledger. So maybe Dassie has some kind of integration with a crypto exchange so that when money comes in one cryptocurrency and maybe goes out as a fiat currency, we can go to the crypto exchange to exchange that. But that means that Dassie, the software, has to contain code that knows how to talk to every crypto exchange, how to deposit and withdraw money from those exchanges. And of course, that code can be very security sensitive because you're having access to the crypto that you're depositing and withdrawing. So that can be very dicey to get right. And so I had this idea that maybe what Dassie does is it just adjusts the exchange rates based on the way the money is flowing. So for example, if there's a lot of money flowing from Bitcoin to XRP, then the XRP just get more and more expensive. And so what that does is it creates an arbitrage opportunity for some trader to come along and say, okay, I'm going to send money the other direction and actually make money. And if that is happening enough, if there are enough people chasing those arbitrage opportunities, then those exchange rates will go back down to wherever the real price is, and the Dassie nodes didn't have to do anything. They didn't have to think about it. And as a result, we don't have to integrate with exchanges. We don't have to worry about how to do liquidity management within the Dassie system. That's sort of externalized into other people who want to go after those opportunities. And so that's another way to reduce the amount of things that we have to implement per ledger. And so with some of these changes, the goal is, or the result is, that we just have the settlement that's left. So if you want to add a new ledger, the only thing you have to implement is, well, how do I send money across that ledger? And that's sort of by definition, the one thing you always have to implement for a new ledger. But the idea is that Dassie sort of takes care of all the difficult things, all the complicated peer-to-peer distributed system stuff. And if somebody wants to come along and integrate their favorite ledger, maybe bring Dassie to a new country or integrate a new currency, they can do that without having a lot of complexity. So that's some of the changes that have happened over the last year. Now a bit of a progress report. It's been a year. I kind of wish I would be further along, but here I am. So we've implemented, or I've implemented a lot of the peer-to-peer network components. So the network protocol, nodes talking to each other. But there's also still a lot of work left in terms of error handling. A lot of the cryptography is not implemented yet. So there's a lot of work to do. The connector right now is pretty rudimentary. And the UI is extremely minimalistic. The only thing you can do is send from one node to another. But we got a foundation, and we also have a testnet. So there are now public nodes that anyone can connect to. So if you want, you can download Dassie and install it, and you can connect to the network. A little bit more detail around some of the features. So there's an installer, which I think is pretty good to use. I'm sure there will be other improvements, but it kind of works. There's an auto updater. I thought that was really important to have early so that when people are developing with the test network, we're going to want to move quickly, make lots of changes, and so the auto updater will update the whole network once a day so that everyone's on the latest version. Other than that, there's no discovery, auto peering, the IOP connector all sort of basically implemented, but there's a lot of important things missing still. And then the settlement right now is purely simulation. So there's no actual integration with any ledger. It is purely just simulating what a settlement might be on a real ledger, but it's not actually doing anything. And now we get to the live demo. The first thing I want to show is kind of the installation process for Dassie. So this is the Dassie land website, dassie.land. That's where you find all the instructions on how to install it. The prerequisites you need to have a Linux server. So right now this is really aimed at developers. For everyone else, just stay tuned. Probably by the next summit, we'll have a lot of cool apps that are building on top of this to show you. You need to have HTTP ports open to the world, and you need to have a publicly accessible IP address. And then you just run this one command. So that's what I'm going to do right now. And hopefully we've had enough technical issues for one talk. So here we go. So it kind of downloaded Dassie, it installed it, and now we get to the initialization wizard. So the initialization, what that does is get us a TLS certificate so that we can have HTTPS. So we need to tell it what is the publicly accessible host name for this host. And hopefully I don't do any typos here. We need to agree to the terms of service of Let's Encrypt, which is what we're going to use to generate the certificate. And then we need to give it an email address so they can contact us. And now it's going through the challenge process. And hopefully we will soon get a certificate. And there we got a certificate. So that's good. And then we can hop over to the browser. Now, everything else we can do in the browser. So that's kind of, we're done in the terminal. We can click on that. And now we have Dassie opening in the browser. And as you notice, that URL contained like a token. So somebody else can't just go to our Dassie node and set it up for us and mess with it. Only we can set it up. And I'm going to generate a new wallet here. So we get a wallet passphrase. Obviously, this is all testnet, so you're welcome to steal my virtual money. But we're going to copy that passphrase and put it into a text editor. So we can say, yes, we've written it down. And now it's asking us to confirm that we wrote it down. So it's asking us for the 10th word, which happens to be tornado. So we're going to enter tornado. And now we have a wallet set up. Now the next step is we need to choose a settlement mechanism. So this is where you would choose, oh, I want to settle with Bitcoin, or I want to settle with XRP, or maybe at some point I want to settle with a bank wire or something else. So really depending on how you want to run your node, this is where you would choose it. Right now we just have a testnet, and we have what's called the stub settlement. So that's what I was referring to earlier, which is a simulated settlement. It's not actually doing anything. It just waits for a second, and then it says, I've settled. So that's what we have so far. So we're going to click on that. And with that, we have a node set up. You get a payment pointer, so people can send money to you. And then you've got a send button, so you can send money to others. And that's pretty much what we have so far. I'll also show you some of the debug features, so you can look a little bit under the hood. Again, this is probably not going to make a lot of sense until you're more familiar with Dassie. But basically, here's the different Dassie nodes. They all have like a randomly generated address. We can see who they're peered with, and then we can see our peering state with respect to them. So I'll not get into too much detail there, but if you're interested in it, please talk to me afterwards, and I will explain everything in excruciating detail. All right, now I want to show you an actual payment. Obviously, that's what you're all here to see. So we have two Dassie nodes running here. One is test1, one is test2. These are two of the public testnet nodes. And I'm going to start by sending $1 from test1 to test2. So I'm going to put in the payment pointer. The reason that loading message disappeared is because it actually did query that node, make sure it exists. And so now I can say continue. And it's asking me how much I want to send, and I'm going to send $1. So now it's asking me to review all the conditions of the payment, and so I will confirm that, and it's already done. Thank you. Now, this is a sort of an opportunity for teaching some things about Interledger. So as you saw, it didn't go in one frame. This might have been a little bit fast to see, but it sort of ticked down, right? Like it's tick, 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 tick. And so the reason for that is Interledger is a packetized protocol. So when we send a payment, we don't just send all the money at once. We actually split the payment up into packets. Now, why do we do that? Well, I mentioned earlier in the talk that we were trying to get the magic of the internet. And one of the things about the internet that makes it so magical is this packetization. Why does that matter? Well, because of the packetization, the traffic across the internet is very homogeneous. You don't get like, oh, here's a big file transfer, and oh, here's a phone call, and here's a video call, and here's something else. No, you just get packets, and the packets all look more or less the same. And that's what allows it to be universal infrastructure that you can use for everything from a file transfer to a phone call. And so if you translate that to money, it is a huge difference for somebody to process a huge payment versus a tiny payment. And so you need very different processes, you probably have different risk management, and so on. And so the way Interledger gets around that is says, well, we're going to packetize large payments so that all the payments that are getting across the network are looking all more or less similar. And so then we can just optimize the risk management for these packets, like processing these packets of money. And that's a really, really important, if somewhat unintuitive, aspect of what makes Interledger magical and support all these different use cases. Another thing I want to show you is when I have two nodes on Dassie that are paired with one another. I mentioned that they have to settle, right? So they can send Interledger packets, but at some point you need to move actual money. And so in order to do that, these nodes, these test nodes, are using what I call the stub settlement system. Now, in this first demo, I only sent $1, which is not enough to trigger settlement, because the nodes trust each other for about $1.10. And so if I want to trigger an actual settlement, if I'm sending more than the trust in the network, that still works, but it's going to have to settle several times over the course of that payment because I'm exceeding the maximum trust in the network. So I'm going to set up another payment. I'm going to send the remaining $4 here. And now what you'll see is you'll see about $1.10, a little bit less, go across initially. and then it's going to stop. And now it's waiting to settle. And then it settles, and then it does another dollar, and so on and so forth. So you can see, like, if you were to send like a huge amount over Interledger, depending on the amount of trust in the network, you might have many, many settlement periods that were involved. And so the way I kind of envision this playing out is that when we first start, it's really going to be best for small amounts. So that means some of the financial access use cases that we're very interested in. That means very technical use cases like AI payments and API payments and other things like that are going to be the first sort of things that this will be good for. And it's not really going to be for big corporate payments until the network has grown a lot and there's much higher trust limits. And then eventually, I think Interledger can serve almost any kind of payment. So that's sort of what it looks like, and that covers it for the demo. So I'm going to hop back into the slides. And with that, I will pause to ask if anybody has any questions. So thank you so much.